So hello everyone, welcome back to the channel Fight, and today we will be discussing about ray optics. So in ray optics, today we will study about the rules to draw ray diagram. Then we will study about the mirror formula and its proof. Then we will study about the linear magnification, and at last we will be presenting you with few special ray diagrams that will be essential in your course. So let's begin with the rules to draw ray diagram. So first of all, I present you up with a concave mirror, where all the principal axis, the focus, the pole and the center of curvature has been marked. So coming up with the first rule. So whenever a ray travels with parallel to the principal axis, it reflects and passes along the focus for a spherical concave mirror. Next, so whenever a ray travels from object through focus and touches the mirror, then it reflects back, which is parallel to the principal axis. Third, whenever a ray passes along the center of curvature, it reflects back along the path from which it has came, and thus the line of travel came and hit the mirror, and then it reflected back along the same path. And last, if the ray of light comes and falls down on point P, then with same angle of incidence and angle of reflection, it passes by. So next, presenting you with the mirror equation or the mirror formula, which will be based on the convex mirror. So here I present you first with the convex mirror. As you can see here, an object AB is placed in front of the mirror, and A prime B prime, an image has been formed behind the mirror. Okay. So mostly in case of convex mirror, we find that whenever a ray falls on the mirror, it has a tendency to diverge away, and thus as all the rays diverges away, so in real we cannot make all the rays meet at a single point, and thus we require to extend all the lines from their divergence point and make them meet at a point which lies behind the mirror, and thus the image that is formed, that will be an imaginary image. So now, starting with the calculations, as you can find with all the notations given here in triangle ABC. So let me change it to the red pointer. So in triangle ABC and triangle A prime B prime C, that will be this triangle. So these two triangles are similar triangle because they have a same angle of 90 degree, as both the object and the image stands erect. Then they share a common angle of angle C, and thus we can say that the third angle will also be same, and hence these two triangles are similar. And with their similarity property, we have written as AB divided by A prime B prime is equals to CB, that will be their base, divided by C prime B prime. Similarly, in the same way, we have obtained that triangle APB, that will be APB, this triangle, and triangle A prime P B prime will also be same, sharing same value of angles, and thus we can also write that AB divided by A prime B prime is equals to PB divided by P prime B prime. So next we move forward to the calculation. Comparing equation 1 and equation 2, we obtain as CB divided by C prime B prime is equals to PB divided by P prime B prime, because the left hand side of both equation 1 and equation 2 are same, and thus we can further extend CB, the length CB, and break it in a form of PC plus PB. So we break the CB length in form of two parts, that will be PC and PB, and further C prime B prime can be written as in the form of PC minus of PB prime. So the motto to break the term CB and C prime B prime is to get the result in the form of known given values, that will be that PC will be the radius of curvature PB will be the object distance and P prime PB prime will be the image distance. And thus further proceeding into the equation, we find the equation takes a form as r minus of u divided by r minus of v is equals to minus of u by v, where pb is considered as minus of u, that is the object distance, p prime b prime is considered as v, that is the image distance. The image distance is in positive and the object distance is in negative as per the sign convention, and then PC, the length of radius of curvature, is also in positive based on the sign convention. So we placed all these values in the above equation and thus we obtain this kind of form of the equation. And further proceeding with the calculations and doing the cross multiplication, we obtain the equation in form as such, and further dividing both the sides with UVR, we obtain the final result of mirror formula, that is 1 by V plus 1 by U equals to 1 by F, and thus we obtain the mirror equation. So now presenting you with the third point of today's discussion, that will be based on linear magnification, and the first case that will be discussed will be based on concave mirror. So presenting you up with a concave mirror where an object AB has been placed in front of the mirror and we obtain A prime B prime as an image that is inverted. So now we know, based on the laws of reflection, we obtain angle I is equals to angle R is equals to theta. And now based on the all the notations that is given, we consider the triangle ABP or the APB, whatever you call, and the triangle A prime P B prime, the smaller part. So here both these triangles will be same or similar because they share common angle theta, and then they have another angle 90 degree because both the object and the image are erect, and thus the third angle will also be same, and hence we can say these two triangles are similar. And thus with the similarity we have written as AB divided by PB, that will be the theta angle or the tan theta of this triangle, is equals to A prime B prime B prime divided by P B prime, and thus further proceeding into the equation by placing the values of AB, that will be h1 height of object, A prime B prime, that will be minus of h2 height of image. Minus sign has been introduced based on the sign convention because the image is inverted, it is inverted downward. PB, that will be the object distance, and PB prime, that will be the image distance. So thus placing all these values in the above equation, we obtain as the equation in the form of minus V by U equals to H2 by H1, and thus we know based on the definition of linear magnification that the ratio of the height of image formed by the mirror and the height of object gives us the formula of linear magnification, and thus the final formula of linear magnification stands as m equals to minus of u v by u as the magnification. So next we will be discussing same true for the convex mirror. So as you can see here, I have presented you with a convex mirror where an AB object has been placed and an A prime B prime image has been formed that lies behind the mirror because it is virtual. And thus with the same principle of angle of reflection, we obtain angle I is equals to angle R equals to theta. Now similarly, considering the triangle ADP and triangle A prime B prime P as similar triangles, we obtain that AB divided by A prime B prime is equals to PB divided by P prime B prime. Further proceeding and placing all the values, we obtain the ratio as H1 by H2 is equals to minus of U by V. So based on the sign convention, we obtain that the object distance will be negative but the image distance is in another side of the mirror, and thus it will be positive. And further, swapping the numerator and the denominator positions, we obtain as h2 by h1 as a form of minus of v by u, and thus we obtain the formula of magnification for the convex mirror. Now we will try to obtain the formula of magnification in terms of image distance and only focal length. For this, we require the mirror equation, that is 1 by v plus 1 by u equals to 1 by f. So we keep 1 by u in one side and write 1 by f minus 1 by v, and thus producting v with both sides of the equation, we obtain as v by u equals to v by f minus of 1. Okay, and thus we know from the earlier obtained formula of magnification, we obtain m equals to minus of v by u, and thus just simply producting a minus 1 with this equation, we obtain 1 minus v by f, and thus f minus v divided by f, and thus we obtain an equation of magnification in forms of f minus v by u when no object distance has been mentioned.